Yes, hi everybody. My name is Mark Heuge, pre-sales consultant cyber at Thales. Okay, next slide, please. So we need more and more, for example, with the concept of teleworking, where we had to make improvements to the networks, but which have become somewhat wild networks, and with Shadow IT, to be able to quickly monitor these environments, to carry out real-time detection, but also to have the possibility of investigating attacks that took place a month ago and to have the possibility to look into the metadata to see what happened. Then there is another need, namely to be able to put a probe in an environment that is not under control, complex and complicated. For example, deploying an EDR agent on an endpoint device can be difficult and may cause additional problems. So we would like to have an immediate response to an incident. So you need to be able to apply a probe very quickly, and the probe needs to be completely transparent and undetectable by an attacker. We need to have an instant view on what is going on. And what is also important is to have a probe that can easily be upgraded with new threat signatures. Next slide, please. So, what's the solution? An advanced next-generation trusted probe, like the Thales Cyber Sensor, is not only an IDS, but also has a number of different additional detection solutions compared to a traditional standard IDS, such as static and dynamic scanning of files and the ability to detect attacks using machine learning. And we will come back to this later on in this presentation. The probe must know how to make a fast and complete analysis. Signature-based network detection based on CTI, cyber threat intelligence signatures, ANSI-feeded signatures, that's the French National Information System Security Agency, or the client or company own written signatures. We have static and dynamic file analysis, both local in the probe, but also connected to a detonation center, so a so-called sandbox. We have rule-based network detections. So besides the use of signatures, also the use of rules and the possibility of building a predictive model using machine learning. What's interesting also is the generation of metadata for further analysis and research. On the one hand, to be used in the probe itself, on the other hand, to be exported to, for example, a SIEM or an external machine learning systems, such as Cyber Analytics of Thales. The probe must be able to decode proprietary protocols. The probe must have the possibility to be adapted to a specific environment by decoding proprietary protocols, such as Modbus or Siemens S7com, etc. And what's also important is the plug and play aspect. It's having a probe that you can deploy immediately and that can begin to detect immediately. Once a tap is present in the network and the probe is applied to the network infrastructure, we can immediately begin to investigate. And what matters to us is that you have a trusted probe that you can trust. So trust the confidentiality, the integrity, the availability of the solution, that the probe detects what it must detect. Of course, we must trust the protection of your knowledge, the protection of the rules, check the integrity of the probe, ensure the availability of the probe, interfacing with your own CTI service, and protect also the output alerts. For example, the communication between the management center of the probe and the probe itself must be encrypted. Next slide, please. Okay. Let's look at the principles. A network detection probe is a piece of equipment or software whose purpose is to observe what is happening in a network in order to detect intrusion attempts in real time. And here's how the sensor, an IDS sensor is working. First, you have a threat analysis center, can be CTI team, a knowledge base, a CERT, cyber emergence and response team, which generates indicators of compromise, IOCs. Those indicators of compromise are loaded into the probe or into a complete detection system. Then the data flows, which passes through the observed network, are passively duplicated via a network tap, test access port, or a mirror port, a span port from a switch or from a next generation firewall, and are sent to the probe. The probe listens to the network traffic in order to detect abnormal behavior or abnormal traffic based on a set of rules. This set of rules is of course based on malware signatures, but also on programmed rules written specifically to detect suspicious behavior. If one of these is detected, an alert is generated and most of the time transferred to a high-level surveillance elements, for example, a CSOC, a cybersecurity operating center. And once a suspicious activity is detected, it is immediately sent to the SOC team so that it can investigate the anomaly and mitigate the threat if necessary. And they can be supported by sophisticated technical means such as big data or artificial intelligence, who complete the diagnosis and decide on the measures to be implemented. This can also be a SIM like Curator, Splunk, or Cybers Analytics, the Thales, and a SOAR, so like Palo Alto XOR, Fortinet, FortiSOAR, Cybers Decision from Thales, and so on. So next slide, please. Okay, let's have a closer look. An advanced probe combines several different detection mechanisms or modules. So first, you have the IDS, intrusion detection system, which provides you signature and rule-based detections, such as using software like Snort or Suricata, and it can therefore use rules sent from a cert or from the manufacturer's CTI, but it can also use your own rules, which are corresponding to your own protocol that you use in your network. Then you have a deep packet inspection module, DPI, which does a protocol analysis and generates associated metadata, and which can generate statistics on this flow, for example, via NetFlow. Next module can be, or is in this case of this Thales Cyber Sensor, a full packet capture module, which records raw data from the data stream. For example, packet capturing via PCAP, to have the possibility of recording packets and using them for forensic research. The files extracted from the stream are sent to the static file analysis component, and which performs a series of static analysis on the file. And in this presentation, the ADS module, the Analytics Detection System module, is perhaps the most important component of an advanced IDS. ADS provides anomaly detection based on algorithmic, machine learning, and behavior analytic engines. Now, let's have a closer look at this. In general, there are two basic. Just the previous slide, please. Previous slide, it was not the. Yes, thank you. So in general, there are two basic approaches in an IDS to detect an intrusion, signature-based anomaly or behavior-based. With a signature-based IDS, the traffic is compared to signature database of known threats, but a new type of attack cannot be detected because the signature of that new type of attack is not present. An anomaly-based IDS, so which is looking at the behavior, is able to detect new, unforeseen vulnerabilities and variants of known attacks. So anomaly-based intrusion detection profiles normal behavior and attempts to identify patterns of user activity that deviate from a predefined or dynamically updated profile. Anomaly-based IDS can also use a sandbox environment to detonate an unknown executable. I agree that static analysis is faster, but if malware is successfully concealed using code obfuscation techniques, it could evade detection. Contrarily, code obfuscation techniques and polymorphic malware hardly evades dynamic analysis as it monitors and analyzes the runtime execution of a program. But this takes CPU time, and dynamic malware analysis hardly keep pace with new attacks and variants. Um, Machine learning algorithms for intrusion detections as such are helping to reduce false positives, are helping to produce accurate IDSs, and can solve many challenges such as speed and computing time. Machine learning uses a workflow that starts with gathering, cleaning, and preparing the available data, and then a model has to be built. This is where the learning task of the machine learning begins. The learning task of an anomaly-based intrusion detection system is to build a predictive model, in other words, a classifier, which is capable of distinguishing between bad connections, intrusions, attacks, and good connections, normal traffic. Rules are used to classify and identify malware samples by creating descriptions of malware families based on textual or binary patterns, and they are like a piece of programming language. So they work by setting a number of variables that contain patterns found in a malware sample. If some or all of the conditions are met, depending on the rule, it can be used to successfully identify malware. And thereafter, when scanning for malware, it is possible to identify unique patterns in that new data stream and change within the malware, which helps identifying to which threat group and to which malware family the sample can be assigned to. And then by creating new rules from multiple samples of the same malware family, it is possible to identify multiple samples, all possibly associated with the same campaign or the same threat actor. And what is key to understand here is that we as Thales, we will provide you with detection rules, of course, but we've got a very efficient CTI team, which provides a lot of IOCs, but you can also create your and deploy your own detection rules autonomously. So in fact, your sensor becomes completely sovereign for you. It's your sensor, and you can have your own cyber threat intelligence strategy in order to detect the most relevant threats for you. So now the next slide, please. Yeah. This slide is a schematic summary of the main differences between a standard IDS and an advanced trusted probe, with therefore also more advanced detection possibilities. Initially, you have a strong and durable durable base, and that's an appliance connected to the network via a tap and is collecting the data stream and attempting to detect malware and irregularities. A click. Yeah. Then we can look at the scalable features, and this is especially where a first important distinction can be made. As you can see, standard IDS compares data with known signatures and does protocol analysis to detect malware and suspicious traffic. But in addition to these standard detection methods, an advanced probe will also use correlation rules, static and dynamic analysis, and those machine learning approaches. This advanced probe will correlate the collected metadata to generate new metadata that then can be used for the analysis of new data flows. In addition, the advanced probe is able to store files, to store data, to use them for forensic research. Click, please. Yeah. And thirdly, we must not forget the integration into a security ecosystem, both in terms of resources and in terms of processing the results obtained, such as the loggings and the alarms. A standard IDS probe typically works with signatures that are loaded into the probe, sourced from a CTI team of the manufacturer. The advanced IDS probe, of course, also supports downloading signatures from the manufacturer's CTI team, but it can also download signatures from other sources, such as Sovereign Cert, a national cybersecurity agency, such as the French ANSI or others. The advanced probe can also be easily integrated with SIMs such as QRadar Splunk for further alarm processing. And of course, the Thales Cyber Sensor Probe integrates smoothly with Thales Cybers Analytics as a SIM and Cybers Decision as a SOAR. In this way, in fact, an automated CSOC, a cybersecurity operating center, can be obtained. So next slide, please. So let's have a look at the user interface. The user interface provides a view of the management and operation of the trusted probes. These are separated into two distinct tasks. Click, please. Yeah. The management center is used to administer the probes for updating the signatures and for updating the software. And click, please. Yeah. Then we have the operations center, and the probe sends the various detection engines of the probe are sending their information to the operations center. So the alerts, the metadata, the logs, and the operator and then has immediately the information at his disposal to process an alert and to carry out an analysis. Next slide, please. Okay, and here's a slide which presents a functional architecture of the integration into a CERT, a SOC, and the probes with the management stations. You have first a detection probe, there can be several of them, which analyzes the flows and send alerts, metadata, and operating logs to feed the operations center. Then you can see the management center, which allows remote administration of the probes. That's so configuration, policy management, the updates, etc. And also for the consultation of the operating logs. And then we have the operations center, which allows operators to process IDS alerts and use the metadata reported by the detection probes. So next slide, please. Yeah, and now, in fact, this is the Thales product, the Thales Cyber Sensor. It's a trusted probe for the detection of cyber attacks designed specifically for the monitoring of critical infrastructures. It is part of the Thales Cyber Security product line. It has been certified by ANSSI, the French Agency for Cybersecurity, as a secure probe and intended to be used by companies which are identified by the authorities as being of vital importance to fulfill their legal obligations. And it combines signature-based detection of network traffic, rule-based detection, and metadata generation to help operators detect malicious traffic and better understand the overall semantics of the traffic. Um, the Talos Cyber Center detection probe can integrate detection rules provided by a CTI service, or you can also um, make your own rules, which then can be loaded into the cyber sensor detection probe. So next slide, please. So the Thales Group itself specializes in development, deployment, operations of large critical systems for civil. So I think of rail transport, air traffic control, aeronautics, satellites, financial transactions, and so on. But also, of course, in military information systems, communications, command, combat, and so on applications. In addition, cybersecurity is a historical know-how of Thales, and this expertise translates into cybersecurity products and services sold as such to external customers, as well as into design and operation of large secure cyber systems. So next slide, please. And this concludes my presentation. Thank you for your attention, and be vigilant, responsible, and above all, be cyber smart. Thank you.